All right, thank you so much for joining us today. In this video, we are going to talk about critical numbers, local extrema, and increasing and decreasing intervals. Now, let's start by talking about critical numbers. Now, critical numbers, they are numbers that when I plug it inside the first derivative, I either get zero or it makes the function not defined. So that is basically critical numbers, right? We will take example very soon for you to understand it better. Now let's look at local extrema. Now local extrema, we have two ways of doing it. We have the first derivative test and then we have the second derivative test. Now we will talk about the second derivative test in the maybe next two videos, but let's look at the first derivative test. So this is basically the definition that helps us to define local extrema, right? I will not talk too much about it, so you can just take screenshot of this and just read through, right? And then we take example and show you how you are going to do it, right? And then we are going to also talk about increasing and decreasing functions, which is basically the definition here. So you can also take screenshots and then just read through and see the definition of increasing and decreasing. But I'm going to use example to basically explain everything that you need to understand for local extrema, increasing and decreasing, and critical numbers. So now we said critical numbers are the values that when you plug it inside the first derivative, the function is zero or undefined. Now we think about undefined whenever the function is a rational function. I mean a fraction, something like a function divided by a function. So this is where we need to think about undefined. But whenever it is a polynomial function, we don't think about undefined. We think about the values that will make sure that f prime is equal to zero. So if that's the case, then the first thing that we need to do here is to find for f prime. So let's do that. What is f prime? Now using the idea that we are differentiating, this is going to give us 6x squared minus 6x minus 12. So this is what you are going to get for the first derivative. So let's try and simplify this. F prime is equal to, here I can factor 6 out and I have x squared minus x minus 2. Yes. And then let's try and see if we can do the factorization here. So this one I can factor it and have it to be 6. So the factors here can be minus x. I think this one, yeah. No, this one should be plus x minus 2x and then minus 2. I think it's true, right? So 1 times minus 2 is this, and this will be minus 1. Good. So I'm on the right track. So this is going to give us 6, and this is going to give us x out, x plus 1, and here when I factor minus 2 out, I get x plus 1. So simplify that, and we have x plus 1, x minus 2. So this is the first derivative, and we said for critical numbers, we look for the values that will make sure that this is equal to 0, right? So it means that what are the values that is going to make sure that this is 0? Now we see that when x is minus 1, this will be 0, and when s is 2, this one will be 0. In other terms, we are trying to say that when I take 6, x plus 1, x minus 2, and it's equal to 0. So you want to make sure that this is equal to 0. So by doing so, we see that we can divide through by 6 and have x plus 1, x minus 2 is equal to 0. And from here, we can just find for x. So we can pick x plus 1 is equal to 0. Then we see that x is equal to minus 1 and x minus 2 is equal to 0. We can see that s is equal to 2. So here the critical numbers or the critical values are s is equal to minus 1 and 2. So this is how you find the critical values. Find the first derivative, set it to 0, and then look for the x values that is going to make sure that the function is equal to what? 0. So that's basically what you are going to do here. So I plug in minus 1 inside the first derivative. You will see that I'm going to get 0. And when I plug in 2, I'm also going to get 0 as well. So that is what we are just doing here. Now that we are done with the critical values, now let's talk about another question. We talks about at what value of x does f has a maximum, local maximum, or minimum. So as I said from the definition, you know, I should have even talked about it small. We are looking at the local maximum and then local minimum, right? So one of them is supposed to be maximum. I think this one's supposed to be typing error. So let me try and see which one's supposed to be the maximum. So if this one is less than 0 and this one is greater than 0, then when I plug in the value, I should be getting, okay, I think this one's supposed to be the local maximum. I think so. I'll check it and see. Yeah. So when this one is greater than 0, right, for all the values in between this, and f prime is less than 0. No. I think this one's supposed to be the maximum rather. Good. Because this one, anytime we plug it in and it's less than 0, and then we have the local minimum. Good. So we will see how we are going to do this here. So now let's look at how we can do it. I use a sign chart. So this is how I do it. I put my sign chart here, and then I put my critical numbers on it. So -1 and 2. So what I'm going to do is, remember we are using the f prime here. Anytime you are doing it, we use the f prime. So this is going to be f prime is 6, x plus 1, x minus 2, right? So what am I going to do here? I'll pick any value here in between this and then above this. So the number that I can pick here is -2. So I pick -2 and I plug it inside the f prime. I pick any value in between this, which is 0, and then I put it inside, and then I can put 3 also inside. So pick any value here, plug it inside f prime, any value here, any value here. So now let's try and do it. Plug in -2 here and see whether you are going to get positive or negative. That's what we are interested in, whether we are getting positive or negative. So plug in -2 here. When I plug in -2 here, I'm going to have -2 plus 1, which is going to give us minus, and then -2 minus 2 is also going to give us minus. Now minus times minus is going to give us positive, so this is going to be greater than 0. It means that this is going to give us increase because this is positive, right? Now let's plug in 0. Plug in 0 here and you are going to have positive because it's going to be 1. Plug in 0 here, you're going to have negative. Positive times negative is negative. So we are going to have this one less than 0, and this one will be decreasing. So minus. Good. Now let's take 3 and plug it in. 3 here will be positive. 3 here will be positive. Positive times positive is going to give us positive. So this one too is going to increase, and we are going to have this one to be positive. Very nice. So what are we going to get from here? Now, when we are talking about local maximum, so local max, we are looking at the x value that maximizes the function, right? So we can see that local maximum goes like this, positive, negative. So anytime you see positive before negative, it means that we are going to have local maximum. So you see that there is negative, sorry, there is positive here, there is negative. So it's kind of increasing and decreasing. And this is going to give us maximum. It's going to have maximum at what? -1. So in between the positive and negative, the critical value which is in between them becomes the local maximum. So this one is local maximum happens at s is equal to -1. And then, of course, local minimum goes like this when you have negative and positive. So you can see that this one will happen at x is equal to 2 because we are going to have negative and positive, meaning that we are decreasing and increasing. So the minimum will be at s is equal to 2. So this is local maximum and local what? Minimum. That's how we solve it. So it means that here, if you get your critical numbers wrong, you are going to get this one too also wrong. Now let's talk about increasing and decreasing. So now let me use the same sign chart to explain the increasing and decreasing. So increasing is the one which is positive, and decreasing is the one which is what? Negative. So we can see that the function is increasing from here and also increasing from here, and the function is just decreasing from here. Now we can see that it is decreasing between -1 and 2. So the decrease basically happens here. And then the increase starts from 2 itself going to what? Positive infinity. and here it's going to negative infinity. So we are going to have from negative infinity to what? Negative 1. So it means that from the graph, the increasing interval is going to be from negative infinity up to negative 1. As we can see from here, from negative infinity up to negative 1 is where the function is increasing, right? And we see another increasing after 2. So we are going to have negative 2 to positive infinity. So this is the increasing interval, right? And then the decreasing interval is just 1, because we saw that it's just between -1 and 2. That is where the function is decreasing. So between -1 and 2, that's where we see that the function is minus, which is decreasing. So that is increasing and decreasing. Now we want to sketch, and for the sketching, we can just basically look at how the graph is looking like from here. But for us to do that, we can plug in -1 inside the original function to find its corresponding y value, and then also plug in 2 inside the function to find its corresponding y value, so that we can get the sketch. So since this one is sketch, I'll just have something like this and have something like this. So we have critical numbers 2 and -1. And we saw that the function is increasing this side and decreasing this side and increasing this side, right? So it's basically going to give us something like this. Let me say, let us increase and decrease. So let me see how the graph is looking like, increasing and decreasing. Okay, good. So the function is kind of like this, increasing and decreasing. This is how the graph is going to be like for the sketch, because I know that at -1 I have a maximum, and at 2 I have a minimum. So that is basically what we're talking about here. So at local maximum, -1, local minimum 2. So that is how we are going to. But the value that we are going to get from here and the value that you are going to get from here is when you plug in the -1 and the -2 inside the original function to give you the y value. Good. Let's take another example, right? Let's take another example and let's see. Now here we want to talk about local max and then local minima, right? And for us to do this, basically we need to find the critical values first. So that is basically what we need, whether the question is asking us to find the critical values or not. So first we need to find f prime of x. So we need to differentiate this using product rule, right? So let me assign a to x to the power 1/3 and b to 8 minus x. When I differentiate a, what am I going to get? So a prime is going to be 1/3 x to the power 1/3 minus 1, which is going to give us -2/3. And then when I differentiate b, I'm going to have -1. So derivatives are very, very important in our math journey. Now let's do product rule. So product rule means that I just multiply this one by this and this by that. So we are going to have minus x to the power 1/3 plus this times that. So I'm going to have 1/3 x to the power -2/3 and then times this. So the rest is for me to simplify before I set it towards 0. So now let's do the simplification and see what we are going to get. So we are going to have minus x 1/3 plus, now this one can be written as 8 minus x divided by 3x to the power 2/3, because this is minus, so I can bring it down here, and then I multiply this one by the 1, and I'm having this. So for us to do this, we need to simplify this. So basically we are assuming that this is to the power divided by 1. So this one will multiply this, then this one will multiply this, then I'll multiply this one by this using the triangle that I told you to do. So, or you can find the LCM if you want to talk about that. So this is second, this is first, and this is third. So first means that this times this, and then second means that this times this, divided by third means that this times that. So we are going to have something like this. Minus x to the power 1/3 times 3x to the power 2/3, then plus, because we have the positive here, then this times that, which is 1 times 8 minus x all divided by 1 times this. So I'm going to have 1 times 3x to the power 2 and 3. Let's try and simplify that. So the top, we are going to have minus 3, right? So minus 3. Now this is x, this is s, the base are the same, so we add the exponent. So I'm going to have x to the power 1 over 3 plus 2 over 3, then plus 8 minus x divided by 3x squared divided by 3. Now let's add this and we are going to get 1. So I'm going to have minus 3x plus 8 minus x divided by 3x squared divided by 3. And this is going to give us something like, let me see. We're going to have something like minus 4x plus 8 divided by 3x squared 3. So you see the process that we need to go through before we can get the simplification form. So now this, we can think of finding the values that will make sure that this is, we can just use this one to find the critical values. Now this is a rational function, so we need to think twice. We need to think about the value that will make this one 0 and the values that will make this one undefined. Now remember that anytime we are talking about undefined, we are looking at the denominator, right? And anytime we are looking at the function that is going to make the value that is going to make the function 0, we are looking at the numerator. So anytime we are talking about zeros, we look at the numerator, and anytime we are talking about undefined, we look at the what? The denominator. So this is what I'm going to do. If I want the zeros, then I'll pick the top, which is 4x plus 8, and set it to 0, and find for x. So 4x is equal to 8, and x is equal to 2. So this is when x is equal to 2, this will be 0. So when I plug in 2 here, this will be 8 minus 8 plus this will be 0 divided by this, and this one will be 0. Now if I want to think about undefined, then I need to pick 3x divided by 3x to the power 2 over 3 to 0. Then when I divide 2 by 3, I'm going to have this divided by 3 is equal to 0, and here x will be equal to 0. So when x is equal to 0, this is what? Undefined. So it means that here our critical values are s is equal to 0 and 2. So it means that since this one is a rational function, you're able to get the one that will make the function 0 and the one that can make the function undefined. We have some questions that the denominator, we don't have any value that's going to make it 0. So it's okay. You can just leave it out and just concentrate on the numerator. Good. Now that you've gotten the critical values, now we need to think about finding the local maximum and local minimum. So I'll clean up the board, and then, or let me just open another page. And then now let's talk about, so we've gotten the critical values. We saw that x is equal to 0 and x is equal to minus 2. Is that right? No, it's equal to 2. So these are the critical numbers. Now for us to talk about local maximum and minimum, we need to use a sign chart. So let's use a sign chart. We are going to have something like this, and we are going to put our critical numbers on it, 0 and 2. But let me go and bring the first derivative. This is what we had for the first derivative. So let me just copy it and send it there. Good. So our first derivative is this. That is f prime of x is equal to this, because we are going to use it here. So pick any value here, plug it inside this. So I can pick minus 1, I can pick 1, and I can pick 3. So plug in minus 1 here and see what we are going to get. So when I plug in minus 1 on the top here, I'm going to have 4 plus 8. And then when I plug in minus 1 here, guess what is going to happen? I'm going to have positive, because this is basically the same as this that you have here is basically the same as 3x squared to the power 1 over 3, right? So this is the same as this. You can use calculator to confirm. So anytime I plug in minus, the square will make it positive. So it's going to be divided by positive. So this one is positive. The denominator too will be positive. So it means that this one will be greater than 0, meaning that it is positive. And we see that this is increasing. Plug in 1. 1 at the denominator will be positive. 1 here, when I plug in 1 here, this will be minus 4 plus 4, which is plus 4. So this one too is going to be also greater than 0. And I'm going to have positive and still increasing. And then I look at 3, plug in 3 here. 3 times this is going to give us minus 12. Minus 12 plus 8 is going to give us something like negative. And the denominator is still positive. So negative divided by positive is still negative. So it's less than 0. This is negative, and this is going to be what? Decreasing. So the question is, now what is, do we have local maximum? And do we have local minimum? So let's see. We said local maximum happens when we have positive and negative. That is when we have increasing and the next 10 is decreasing. So let's look at here. This one was increasing, but when you move to another one, it's also increasing. So there is nothing happening here, right? And then when you come here, this is increasing and this is decreasing. So positive, negative. So the local maximum will happen at x is equal to what? 2. But do we have local minimum? No, because local minimum should be going with decreasing and increasing, and we don't have any decreasing before increasing. So it means that there is no what? Local minimum. So we don't have local minimum. So no local minimum, right? Good. So that is basically the local maximum and minimum. Now let's talk about increasing and decreasing. So basically, as I said, increasing, this is also increasing, and this is decreasing. So this one is very quick to write. So as soon as you're able to, find out draw your sign chart, increasing and decreasing become bonus after testing. So increasing interval is from minus infinity up to 0, and from 0 up to 2. So that's what they're going to have. So from negative infinity up to 0, and from 0 to 2, because they are all increasing or increasing. And then the decreasing interval will be from 2 to positive infinity, because we have it this way. So this one, what the hard work here is how to figure out your critical values. If you're able to figure out your critical values, then the rest is just draw the sign chart and figure out whether it is increasing or decreasing, and you'll be able to find out your local maximum and minimum, and then your increasing and decreasing interval. Now let's look at this function here. Now find the domain, right? I just added this one to this. Now we want to find the domain. Now domain, we look at the denominator, right? But we need to also look at the numerator, right? So what we can see here is, now the domain, this function here, x, should never be 0, because anytime x is 0, the function becomes what? Undefined. But look at the function here. The len function 2 says that x should be greater than 0. So because if we exclude only 0, then it means that we can think of -1, -2, and then positive values except 0. So all real numbers except 0. But when you put in, let's say, negative value on here, this one too will be undefined. So it means that the domain should be x greater than 0. So x should be greater than 0, or in other words, we are going to say 0 to positive infinity. That will be the domain. That's going to define the function. Now let's go ahead and do what we wanted to do. We want to find the critical values. So we need to find f prime of x. So this one, we are going to use the quotient rule, right? So quotient rule, we have f of x, which is equal to the len of x. So I'm going to allocate this one for u and this one too for vn. So it means that my u is len of x and my vn is x. What is u prime? When you differentiate len x, what do you get? 1 over x. And when I differentiate x with respect to x, I'm going to have 1. So product rule, this times this and this times that. So I'm going to have 1 times len of x plus x times 1 over x. So this will be f prime. So let's try and simplify that. This is going to give us len x plus 1. So the question is, what are the values that is going to make sure that this is equal to 0? So this is what we are going to do. We are going to set f prime to 0. So for critical values, f prime of x should be equal to 0. So it means that ln of x is equal to ln of x plus 1 is equal to 0. So ln x is equal to minus 1. Then for us to find x, we need to get something like e to the power ln of x is equal to e to the power minus 1. And it implies that x should be equal to e to the power minus 1. So e to the power minus 1 is a critical value, because when I plug this one inside this, I'm going to get minus 1. Minus 1 plus this is going to give us 0. So x is equal to e to the power minus 1 is the critical value. Then if that's the case, then let's try and figure out our local maximum and minimum. So let's put it on the number line e to the power minus 1. So f prime, we had it to be this plus 1. So the real question is, now we need to pick any value here. So the question is, what is e to the power minus 1? So e to the power minus 1 is basically the same as, let me say, 1 divided by e, right? So this is the same as that. So what is 1 over e? So 1 over e is approximately, let me say, 0.3679. So it means that for us to get any value here, we can pick something like 1, right? No, here we cannot pick 1. We can pick something like 0.5 on this side, and then here we can pick something like, no, 0.5 is bigger than this one, so we can pick something like 0.1, and we can pick 1 here, right? So basically we need to pick f prime of 0.1, and then we pick f prime of 1, right? So for 1, when I plug in 1 here, then 1 is 0, so 0 plus 1 is 1, and it's positive. So I see that this is greater than 0, and this will be increasing because this is positive. Now plug in 0.01, and let's see what you are going to get. So ln of 0.1 is negative. So negative this plus 1 is going to give us negative, because ln of this is like minus 2 point something. So this is going to be less than 0, and we are going to have it be negative, and this one will be decreasing. So it means that here we don't have local maximum, we just have local minimum, because we have negative and positive. So we have the minimum. So here we have local minimum at x is equal to e to the power minus 1, or 1 over e. So that's what you are going to get from this. Now increasing and decreasing interval. So this is kind of bonus, because we come here. So this is going to be increasing interval is going to be from e to the power minus 1, or let me say 1 divided by e up to positive infinity, and then the decreasing interval is going to give us from minus infinity up to 1 over e. So kind of very simple from this one. Good. Very simple from this one. Now let's look at question 4. Good. So question 4, they've given us f of x, and they've given us f prime of x already. So I think it's kind of very simple for us. So what we need to look for, we want to look for where the function is increasing and local maximum and minimum. So since they've given us f prime, then we need to figure out the critical values. So let's do that. So as I said, anytime you have your f prime, which is in the form of a fraction, pick the top, set it to 0, pick the down, set it to 0. So I'm going to pick the top and set it to 0. So x will be equal to 5. I'm going to pick the down and also set it to 0. And this minus this is equal to 0, and x is equal to 1. So here the critical values, are s is equal to 1 and 5. So kind of very simple from this one, because We didn't do any hard work because they've given us f prime already. What we just need to do is we need to have this one on the number line, and then we have 1 and 5 so that we can figure out where the function is increasing. So f prime of, we can pick 0 from here, we can pick 2 from here, and then we can pick 6 from here. Good. So now let's plug in 0 here. When I plug in 0, the top will be positive. When I plug in 0, the down 2 will be negative, because 0 here minus 1 to the power 3 is still minus. So positive divided by negative is going to give us negative. So it means that this is less than 0 and is going to be decreasing because it's minus. Let's plug in 2. 2 here is going to be positive. 2 here is also going to be positive. So positive over positive is going to give us positive. So this is increasing. Let's plug in 6. 6 here is going to be negative, and then 6 here is going to be positive. Negative over positive is negative. So we are going to have this one less than 0, negative, and this one will be decreasing. Interesting. So what do we see here? Increasing is just that. So increasing interval here, increasing interval is going to be from 1 to 5, only this one, which is going up, which is positive between 1 and 5, and then the decreasing interval is going to be this and that. So from negative infinity up to 1, and from 5 to positive infinity. So we're having negative infinity up to 1, and we have 5 to positive infinity. So that is the increasing and decreasing interval. Now, last one, we can talk about local maximum. Local maximum, which is local maximum is happening here, right? Local maximum, positive, negative. So at s is equal to 5, and then we can talk about local minimum. That is at 1, because here we have negative, positive, and it's concave up, something like that. Good. So this is the process of finding critical values and finding increasing and decreasing and checking for local maximum and minimum. So I gave you this trial question. I know question C, I cannot get it, but you can try it. But I want to see your critical values. I want to see your local minimum and maximum, right? And then I want to see your increasing and decreasing interval for this question. And then you can mark the graph question yourself, right? Good. So what we are going to do is, in the next video, we are going to talk about absolute maximum and absolute minimum. And with that video, you'll be able to differentiate local maximum, local minimum from absolute maximum and absolute minimum. So see you in the next video.